Yeah, so as Kenton said, I'm Noah from the Danforth Center, and David will also be talking. I'll give a brief introduction to some of the things we're doing on the Danforth Center side. But David and I met about 4 years ago, I think, as part of this TERRA-REF project.
Before you go on, Noah,
yeah.
let me just kind of set the stage here. So all the presentations have similar goals, is to kind of basically present their research, present their needs, and how they're using Clowder to do that. So Noah will be the first one doing that with regards to phenomics. And the idea is for the first time for you guys to see what each other is developing. So with regards to working with us, you'll notice that once in a while we'll, pause on pushing out a new feature. It's because one of you has a production instance that needs a certain thing. And so we have to make sure that still works. Sometimes you'll need a feature and it just comes out of the blue. It's because you're leveraging an activity from one of you that also works for us, others. And so over the years, there have been a lot of these things. There's, all that table, there's been tens of millions of dollars poured into this thing. So the idea is to kind of see those aspects, what I can leverage, collaborations you can work out with one another to kind of take that next step. So Noah's the first with regards to biology. No.
Cool.
So, sorry.
Oh yeah, no, that's good. So the space we work in, this high throughput phenotyping, this is where David and I want to work on the computer. We don't want to go out to the field and measure plants. So we want to be able to measure plant shape, physiology, morphology with remote sensing. And this has a lot of other side benefits in that we can measure things non-destructively, which lets us do repeated measurements, and ideally we can do frequent visits, whereas going out to the field is a lot of hard work, takes a lot of people, and so it's harder to do more frequently. The downside is that sensors can be expensive and the data aren't always the easiest to work with, and how we interpret the data from the sensors to make sense of biology can be tricky. But the TERRA program that David will talk about in a minute is one of these big programs that was funded through the Department of Energy that put a lot of resources into a lot of sensor technology at field sites so that we could really start to investigate this at a high level. I'll just say, like, one of my other interests in Clowder through this collaboration with David and others has been that it's actually a really useful platform beyond just the TERRA-REF program, because we have a lot of other phenotyping platforms at the Danforth Center. Just really briefly, the Bellwether facility is a growth chamber-based system where the plants move around on a conveyor belt through imaging cabinets. We've got a couple X-ray CT instruments where we can look at roots or look inside of plant structures. Hyperspectral imaging robot on an arm. And then we also do a lot with low-cost sensors, so using Raspberry Pi computers to outfit growth chambers with just simple RGB imaging, but where we can image thousands of plants simultaneously. So far, what we've done is really simple and not always that effective. So we have all these data sources that just drop data onto a standard file system. So there's really no structure to it. And what happens is the data gets stale. It just sits there for days, weeks, months, years before someone comes along to analyze it, or people re-download the data from the source because they didn't realize someone else downloaded it. So there's just, the status of the data is just kind of unknown to most people. So it really, I think, slows down this process of getting the data out, publishing it, sharing it, and whatnot. So that's where I could see Clowder really helping us plug in all these data sources into this platform that helps us meet the FAIR principles. And it should ideally decrease the time it takes to actually make the data usable. One of the things my group works on is image analysis software. So we have this project called PlantCV. I won't go into the details, but it's a Python package, and it was designed to be modular so that we could build custom image analysis workflows by stitching together lots of simple image processing tasks. So this is just an example of one of these workflows that's built. And then once you build a workflow that can work on a data set, you can do parallel computing to analyze the whole data set using that workflow. Oops. Right, so within, I'll just put that up. Within the TERRA-REF project, we've been using PlantCV a bit for some of the data sets that we have. And one of the things I'm interested in, right now we do a lot of parallel computing just on single machines, but we'd like to make PlantCV more usable to users who don't really care about infrastructure. And so on the one hand, sort of for people who are installing PlantCV on their own, we've been working on integrating it with like workflow management systems that can talk to lots of different infrastructure so that the user doesn't have to worry about that side. But on the other two places we've been working on this is through integrating with something like Discovery Environment and Cyverse to handle this same problem. And then of course Clowder also does this too, where the user doesn't really have to know all the infrastructure details in the background. When we build workflows, we typically do this using Jupyter notebooks. I'm just showing an example here where you can go to our GitHub repository and you can launch a binder container and run through some of our example workflows with data preloaded. So if you want to see what PlantCV workflows look like. But one of the things that I kind of wish we had would be that within Clowder we could use Jupyter to build workflows and then convert the notebooks into extractors. That's something I'll throw out there as a wish list.
Clara, you mentioned that too.
Another thing that we're really interested in using Clowder for is machine learning and deep learning. This is just an example of work that Wen Xiao's done. Wen Xiao came with me today. This is using maskr CNN to segment leaves of these Arabidopsis plants. But just in general, if we could use Clowder to both collect and organize training data for machine learning and then deploy the models, that's something we're also really interested in doing. So I think with that, I'm turning it over to David.
And I'll just point out that too is another common need that maybe Luigi will touch on later too.
Good, because I'll also touch on that, I think. So, yeah, so I got to meet Noah, and I've been working with Rob and Kenton for much longer than this project in particular, but this helped to get me involved with Clowder, the TERRA-REF phenotyping platform that Noah spoke about earlier. This platform, the intention is to deploy the best sensors that are commercially available and get very high resolution data sets off of crops for phenotyping, as Noah was talking about, and make the data publicly available to the community so that, because as he was mentioning, these sensors are difficult to use, there's a lot of science and engineering still evolving there. Making the data available for everybody to use means that not everybody has to start from the beginning, especially in purchasing and deploying this expensive equipment. This is our flagship platform. We call it the largest agricultural robot in the world because nobody else has told us differently. And it's very large, just for comparison. So this is a shipping container, and then this right here, about the size of a large van, is a sensor box, and it can go in 3 dimensions, and it scans the field once or more per day. The idea behind the open data and computing that we're putting out is to enable biologists, engineers, and scientists to all work together on this problem of making crops more productive, on linking phenotypes. Anything you can measure about a plant is basically a phenotype as opposed to a genotype, which is what programs the plant, or the environment, which interacts with the genotype to create what you observe. So in order to make breeding faster or agronomic management more efficient, we needed to get all of these groups together, and so ARPA-E put a lot of funding into bringing groups together from all these different domains to solve that problem. And our team was the public reference data team, and as you can see, it includes people from many different universities. So given the short amount of time, I didn't give you a whole lot of information about the results that we've had so far. We have our first data publications coming out this fall, but I wanted to talk something about like where we're going from here. The first thing that I've been working on over the past year is taking the pipelines that we've developed and making them available for drones and tractors. So we've got a drone processing pipeline coming out. It's in its alpha phase at this point, but the idea is that the same infrastructure that's used for that big machine, not everybody, in fact, we don't expect most people to purchase big machines like that, but almost everybody, when I walk into a scientist's lab or office, I often see a drone there, and so making that pipeline more consistent all the way from collection and ingest to curation of the data will make science more effective. People buy the machines and then don't necessarily know what to do with it, with the data that comes out of it, sorry. Indoor phenotyping is NOAA just covered. And more importantly, I want to talk about a number of people after this project have started to ask me about how they can deal with data from very large systems, controlled environments. So I've got a picture here of the Biosphere 2, which is out in Arizona. It's an enormous controlled environment with a lot of experiments going on inside, a lot of very heterogeneous data, huge sensor networks. And then on the bottom is controlled environment plant growth. It's a great opportunity scientifically, and also because the data is regular and there's a lot of advance that can be made there by understanding how the plants are growing under, you have almost an infinite number of environments that you can provide to those plants. And finally, again, I'll reemphasize, and this was also supposed to be a pitch when Praveen was here, but I wanted to say that there's a lot of networks out in the field. The CZO, which is involved with Clowder, a number of them are. I don't know that the Arizona one is, but we have this similar problem, and if we can harmonize our data sets, then science will be more efficient. So I gathered that Kenton's request, and I apologize, some of these, well, this one down here got adjusted, but the Kenton wanted some requests, and so here's my top 3 requests. So one is to facilitate interoperability, just the fact that we've got people from related domains here. One of the things that we can do, not just at the level of the infrastructure itself, but also in the choice of the data types, the vocabularies, infrastructure, APIs that we're providing. If there's communication, which I guess is part of the point of this meeting, among us, then we can, even if there's not one thing to agree on, at least we can start talking about how not to have to make things up on our own and adopt what's available. Second is a little bit about what Noah was talking about, going from a Jupyter notebook to a automated pipeline, so facilitating algorithm contributions. I see in our projects this is a big stumbling block. You have a computer scientist who can come up with really something cool to do with a file, but then once you want to deploy it and automate it, there's a lot of challenges. So this picture right here is just a quick checklist of all the steps that are required that include testing, getting feedback, documentation, etc. All of these steps, I think, could be automated and facilitated somehow, and I'm not sure how. That's why it's a challenge and an opportunity for our community. And finally, enabling people to do annotation. So this is just a question that I get asked a number of times, like, how do I store data in a way that computer scientists will find it useful? Or how can I annotate images in a way that will make it useful, or quickly and efficiently? And so I know that Clowder has some basic functionality, but there's other tools that provide advanced functionality that I think would be useful. So with that, I apologize, especially Noah, your name got blacked out when I put the header on there, but the TERRA-REF project is the product of enormous collaboration, as I mentioned, and there's 5 times as many people who have been involved in the projects overall. So with that, thank you very much.